All right, so with 11.8 is our last topic here. It's expected values. And expected values are the probabilities over long term or the long run. Okay? And usually how we go ahead and find these is to multiply each outcome by its probability and then add them together. All right, so we're going to do 3 examples of this. Example 1, a pointer can land on 4 regions. What is the expected value? Okay, so assuming each of those 4 regions are independent, right, means the probability for each region is 1 over 4. Right, which means if it lands on 1, it has the probability of 1 over 4 of doing that. If it lands on 2, it also has the probability of 1 over 4 of landing on that. If it lands on 3, has the same probability. If it lands on 4, it has the same probability. Okay? Which means we're going ahead and adding some fractions. You could do this in your calculator also, but we have 1 over 4 plus 2 over 4 plus 3 over 4 plus 4 over 4 are 1, right? And if I go ahead and add all these together, 4 plus 3 is 7, 10 over 4, which is about 2.5, which is 2.5. Okay, so my expected value is 2.5, and what I did is took the probability and multiplied it by each region there. Okay, so we're going to look at a more practical example of expected value for drivers. And this is taken straight from page 145 out of your workbook. All right, and my expected value is all these things multiplied and added together. Okay. So I have 0 times 1 cent. This is going to cancel out. I have 2,000 times 15 cents. 4,000 times 8 cents. 6,000 times 5 cents. These are actually in money form, or probability. I shouldn't say cents because it's in probability. 8,000, 0.01, and 10,000 times 0.7 or 0.70. If I multiply these and add these together, I end up with 8,000. So that's my expected value. So part B of this would say what would be a practical idea of this number. Okay, the company should charge a premium so that it doesn't gain or lose money, and it should charge $8,000 for that. Okay, one more example. This is example 6. This is on page 147. So a game is played using 1 die. If the die is rolled and shows 1, the player wins $5. If the die shows any other number, the player wins nothing. There's a charge of $1 to play. What is the game's expected value? All right. So let's go ahead and look at this. So in order to win, okay, so I have a die. And so I have the numbers 1, 2, 3, 4, 5, and 6. Okay. If I roll a 1, I win $5. But remember, I won $5, but it cost me $1 to play. So if I roll a 1, I only win $4. Okay, so this is my gain or loss. So in this case, if I roll a 1, I gain $4. I had to use $1 to play. If I roll anything other than that, I win nothing, but I still lose the $1 that I had to pay to play. So any other number, I lose my $1 that I paid to play. My probability for all of these, because it's one die, is 1 over 6. So I have an equal chance for each one of them. Okay. And what I need to do is I need to go ahead and add these together. So I will gain $4 if I roll a 1, and I have a 1 over 6 probability of doing that. Any other number I lose, I have a 1 over 6 chance of losing my $1. Okay, and each of those is multiplied by 1, a -1, so they become negative. Instead of adding, we're subtracting. 1, 2, 3, I need 2 more. And if I go ahead, put these in my calculator, I end up with a negative. Okay, but we're repeating 6. Okay, so that means I have a negative, or a 0.7 probability, which means this negative means it's a loss, so I can expect to lose over the long term. All right, so that concludes this section. I will see you in the next chapter.